Hi, everybody. So sorry about that. Technical difficulties. My computer decided to update for the first time ever, apparently, because it completely locked me out. Anyway, hold please. Let me start. Let me pull up the slides and we can get started. Luckily, we don't have a whole lot to go over today. We went over the reproductive system pretty in depth so far. Today is just finishing out that PowerPoint. And then I'm here. So if you guys have any questions about the next test, the final, anything at all, we can kind of use this as an impromptu study session or review session, or we can end early and take a break and whatever. So it's up to you guys. Hopefully it's repetitive. Okay. So it's been a weird day. Weird day. All right. Here we go. Share. Cool. There. All right, so real quick, as a brief recap, we went over the reproductive system, including all of the organs. So the male reproductive system starts with the scrotum and testes, sperm moves into the epididymis and out into the straight tubules, and then through the vas deferens, all the way out to the urethra eventually, where it's joined by different glands that add seminal fluid to it. And then it's ejaculated out, right? Um, for the female physiology or the female reproductive system, eventually that sperm enters, obviously, into the vagina or the vaginal canal through the cervix, where it meets with an egg. That egg is released from the ovaries. It's picked up by the fimbriae, and then it makes its way all the way down the uh, uterine tube. Remember, say fallopian tubes in this class, right? And then from there, it makes its way into the uterus, meets up with that sperm, has a good time, baby's born. Okay. Um, the other aspect of female reproductive system that we don't have on males, it exists, but it's not like this, right? Is the breast tissue where milk is produced in the alveoli, makes its way down into the lactiferous sinuses and out into baby's mouth. Okay. Um, remember, spermatogenesis and oogenesis are relatively the same, right? We have mitosis and then we have meiosis 1 and 2. In oogenesis, meiosis arrests in prophase 1. So we're only going through half the process. And then it resumes later in life while you're ovulating, right? We talked about the ovarian cycle. So there's different phases of it. First, the oocyte matures, then it's released, and then it makes its way down the ovarian tube and basically devolves from there, right? Like it's a normal egg, and then as it moves down, it turns kind of into this like degrading little egg, right? This is all maintained by hormones, right? And those main hormones are going to be FSH and LH, and estrogen and progesterone, right? So in the female body, a surge of FSH and a little bit of surge of LH, as well as a drop in estrogen, kind of kickstarts that ovulation cycle for the egg to be released, right? So we're releasing estrogen to mature that oocyte, and then eventually we hit a threshold where FSH surges, the follicles release, and then it drops off, and we go through kind of the end of the ovarian cycle, right? Um, and then as we kind of get to the end of it, day 28 in most normal anatomical females, we start to approach a period of shedding of the uterine lining, right? And that starts on day 0. Okay, cool. Any questions so far? I know we kind of blasted through that, but did you guys have any questions for doing that on your own? It's pretty simple. There's only 4 hormones responsible, a lot of negative and positive feedback. And they're roughly the same hormones in males and females. Estrogen and testosterone are pretty autologous, right? So, analogous. That's the word. All right, let's talk about contraception. Let's bring it from anatomy to sex ed. All right, contraception. So there's a couple different types. Obviously, condoms, right? Those are your barrier contraceptions, right? So what you're doing here is you're stopping the sperm from ever even reaching the vaginal canal. So obviously that's pretty effective. Diaphragms, all that stuff exists. The way that these female contraceptives work generally is by disrupting the hormonal cycle. Okay, so if you have progesterone only pills, if you're taking progesterone on a constant basis, you never have that surge of estrogen. Okay, go ahead, buddy. Thank you. All right. You never have that surge of LH that releases, or FSH that releases the egg, right? So you never end up with the egg being released, right? Or you release it and you have other pills that kind of slow down the movement through there. So those all exist. Let's see, what else are in here? We also have male sterilization, right? So this is where the dichostephens is cut, hopefully both sides, right? Not just one side. And then usually it's cut, burned, and tied, and they kind of fold it over a little bit, sometimes stapled, depending on the doctor. And it goes through this process. So this is a relatively minor surgery. Getting your tubes tied, obviously, is like the female component of that. A little bit more in depth, kind of more of a surgery. Usually an option after like a C-section delivery where the uterus is like readily available, right? Like it's like right there. A little bit easier for males to go through a vasectomy procedure, right? Barrier failure rates are generally caused by, fun fact, most barrier failure rates are increased because of misunderstanding how to use them. So, banana, condom, I've taught you all you need to know. So yeah, they're not generally like a breach in the actual device. Hormonal, with the oral or the ring contraceptive, the failure rate's around 8%. Injection kind of keeps a more stable, an implant kind of keeps a more stable hormonal response. Again, these oral contraceptives are, you forgot to take the pill. What are you gonna do about it, right? With the injection, it's every couple of months, so you never really forget unless you just forget to go. Withdrawal, 27%, risking it, okay? Don't do that. I don't care what they say. Sterilization, which would be one of these options right here, less than 1%. The reason for that is we're just not getting that sperm to the tube, right? Sometimes these can refuse, but hopefully you have a good doctor that ties them off as well. So if they do refuse, they're actually tied and they'll kind of mush together as they heal. For females, kind of the same thing. Sometimes they can refuse. The other thing to think about for ovarian sterilization versus, or not ovarian, uterine tube sterilization, right? So tubes tied versus vasectomy, is the egg is released from the ovary and it gets picked up by these fimbriae, right? So if this stays open and it never really heals, that egg might be released over here, and it's not a far shot. Eggs can travel, and ectopic pregnancies in weird places can totally happen, okay? So a little safer to go the vasectomy route than the tube tied route. because the risk here, especially, is if this fails and becomes an ectopic pregnancy, and an ectopic pregnancy is a pregnancy that's not in the uterus, it's pretty much that. Um, uh, Big consequences, right? So we can, if you have a baby growing out here that's just not in the uterus, or if it's implanted here, we can rupture, we can bleed, you can die. Okay, so things to think about when it comes to that. And another thing, I don't like to throw politics into it, but because this is an anatomy class. But at what point should a doctor say, I don't know, it's an ectopic pregnancy, but it's 25 weeks. Who knows? So I won't give you my opinion on it, but I just want you guys to think about that those kinds of things can happen with pregnancies that are ectopic. With vasectomy, you don't really run that risk as much, right? Because you're just cutting this tube and this will function as normal, okay? So, also, vasectomy, not a big deal. Doesn't even hurt that bad. Cool. Any questions about contraceptives? Your options. Use one of them if you don't want babies. No? If you have any more questions about contraceptives, go ask your parents why they failed you. Okay? STDs are bad. They're bad. So they can cause anywhere from pain to blindness to death. Okay? Don't get STDs. Use contraception. I guess this is like a state thing that I have to put this in. I don't really know. All right, male and female reproductive development. Any questions about STDs or contraception or any other things that you should have learned in 10th grade health class? No? Okay, great, awesome. Well, I don't have time to talk with you guys. All right, male and female embryological development. Okay, so let's look at a graphic real quick. And because my computer was stupid, I do need to go search for this graphic again. Okay, hold please. There's one. I'm trying to look for one where it kind of shows where it's moving. This one's a U-ish one. All right, this is kind of. I think it's what I was going to tell you. Okay, it is what I was going to show you actually. All right, I like U-mesh stuff. They're pretty sweet. So I'm going to show you kind of this instead of the slides. Right, this is what we're talking about. The slides are not that amazing. Okay. All right, so starting at 8 weeks in development, everything up to 8 weeks, an embryo develops the same. Male, female, black, white, whatever. They're all the exact same, okay? And development doesn't change. Just throw that out there. All right, so embryos' genders are not distinguishable for the first 6 weeks, and really them more closer to 8 weeks, okay? Around 8 weeks, we start having SRY expression. And SRY is a gene, and it's actually found on the X chromosome. I'll show you. Okay. It's actually, oh geez, I broke it. It's actually found here on the X chromosome. Fun fact. This is the male determining gene, okay? So in the presence of a Y chromosome, so if you have an XY gonad, it's gonna express SRY on the X chromosome, and that will begin the process of developing female genitalia or male genitalia, okay? And that process is determined by whether or not a Y gene exists in the embryo, okay? So if each cell has a Y gene, that will tell the SRY region to start producing male body parts. Otherwise, you pretty much defer to female always, okay? There are different variations. Like you could have a Y chromosome, and the SRY gene might not be activated, right? That would be like an abnormal thing. So you could have a biological female who has a Y chromosome, right? So things can get jacked up kind of all around there. Not that people with genetic differences are jacked up. I just am trying to express that things can change within normal anatomical variation, okay? So after around 8 weeks, don't get too in the weeds on these right here. What's going to happen is we will have, if the ovary and the testes are kind of the analogous pairs, right? And then the fimbriae and the uterine tube are kind of the analogous pair of the ductus deferens. In a male, right, that will all kind of attach and become one, okay? One thing to kind of point out that I want to show you guys, the kidneys are developing right here, down here, okay? And the reproductive organs are developing up here. So I know what you're thinking. That's not where they're supposed to be. And you're right. They actually will kind of swap, okay? So the kidneys will ascend into the posterior retroperitoneum, and then the reproductive organs, so like the testes, the ovaries, will actually descend down into the pelvic region, okay? So different anatomical variations can happen, right? Like sometimes you might get one tangled up, or like a ureter that's looped under ductus deferens, right? So things can happen, okay? All right. So and that happens around the 28th week of development. So if you are developing normal external genitalia, if you're a male, your testicles are not going to descend into the scrotal area until about 28th week of development. Same thing if you're showing normal female external genitalia, your ovaries might not descend until about the 28th week. Okay. There are different folds that kind of happen within here that create like the urethra and like the different tubes that exist. And those can cause normal anatomical variations, right? So hypospatus, I won't show you guys any pictures, but hypospatus is like the urethral tube, the urethral opening, where it could be, instead of on the tip of the penis, it could be like at the base, right? Or it could be kind of off-centered a little bit or something like that. So that's just because these are moving around and you're replicating cells in tubes and you're moving them up and down. And because you're doing that so quickly, you might run into a situation where you have some anatomical variation normally, okay? Intersexuality, so this is like an XX or an XY and the external genitalia is not being produced. That has to do with kind of the development of the hormone regulation, right? So you might develop external genitalia for one, but you're internally that never happens, right? So like a male external genitalia might not actually fuse right here, and you might have ovaries, okay? And that's because this whole process happens kind of so close to each other, and we're kind of swapping and moving and shifting stuff so much that things can get a little discombobulated, okay? So most tissues have bipotential, right? That's that potential to go either way. And other reproductive structures are developed from those embryological ducts, right? So we're talking about the seminal vesicles, the deferens, stuff like that, all developed from those those first embryological ducts, okay? All right, so you're born, right? And you have, let's say, normal external genitalia, everything's fine on the inside, good to go. Eventually, we're going to go through this process called puberty. Oh, geez. Okay. All right, so puberty is triggered by age, roughly. Age 8, it kind of starts kickstarting that time, right? And uh, the production of GnRH starts. Okay, so it's pretty low to begin with, and then around age 8, it kind of bumps up a little bit, and then it stays up there until it kind of tapers off towards when we die. Okay, so that triggers the anterior pituitary to release luteinizing hormone and FSH, so LH and FSH, the big ones, right? And that will cause increase in testosterone production in the testes and estrogen in the ovaries, right? So both the testes and the ovaries produce both, right? Because males have estrogen, females have testosterone, obviously. But in a normal male, you'll produce much more testosterone, and a normal female, you'll produce much more estrogen, okay? Those sex hormones are released, and you'll kind of start to mature, right? This is when we start seeing those like more mature parts. Okay. In males, it will also produce spermatogenesis. In females, it will produce folliculogenesis. Okay, so if in females after puberty, we start creating those follicles, right? What we're doing is we're taking those 2N cells that have arrested and we're saying, hey, you can wake back up now. Okay. So it's kind of like freezing your eggs until you're 8. It's basically what's happening. And at some point, they wake back up and they start functioning normally, hopefully. All right. Disorders. So we can have different types of cancers, right, in all of these tissues. Impotence, so a lack of either motility or like some form of sterilization, right? We can have cancer in the ovary, cervical, or breast. Estrogen is heart protecting, right? So it does lower your chance of having a heart attack if you produce more estrogen, aka normal female. But it does encourage cancer, right? So we can have ovarian cancer and breast cancer. That's why we see them in such high numbers, especially younger females. Okay. STDs, I won't show you any pictures. I don't think you want to see them. Just know if it looks bad, it probably is bad. Go get treated. Amenorrhea, so no menses, chorea, right? So the menses aren't working, so you don't have a period. Dysmenorrhea, abnormal period, and then endometriosis. Let's talk about some of those. All right, cervical cancer. This is gonna kind of be a little primer on cancer. I don't know what other classes you guys are taking, but cancer can happen in basically 2 ways. Okay, it can either start. It can either be cells that are proliferating too much, or cells that will not die. Okay, throughout their cell process. Okay, at one point in this, if this is the lifetime of a cell, right here, you reach these checkpoints. So you have a G1 checkpoint right here, which is where the cell grows and grows and grows, and it goes, hey, can I go through DNA synthesis? And then the cell says yes, and then you go through DNA synthesis, and then cell division. Okay, so you do DNA synthesis, and then you grow a little bit more, and you go through this G2 checkpoint that says, hey, can I divide now? And the cell says yes, and then you go through there. Okay. Now, during that G2 process, and this is why this has to do with like STDs and stuff, HPV, which is a virus, human papilloma. Let me Google it. Virus. Papillomavirus. Papillomavirus. Skipping a thing. Okay. Yeah, papilloma. Yeah, I couldn't remember if it was papilloma or papilloma. I thought it was papilloma, right? So HPV, if it's present, it causes issues in a mutation in this p53 gene, okay? And that happens within the cervix. Also, you have estrogen in here too, so that's promoting cell growth, right? Why do we have a promotion of cell growth in the cervix? Anybody? Anybody? Bueller? Correct, because we're shedding the lining of the uterus, right, which is next to the cervix. Okay, so we've got that estrogen that's producing a lot of cells, right? If HPV is not present, the cell will detect that mutation, and at this G2 checkpoint, it will say, hey, if you're jacked up, don't divide, okay? And we remain with a healthy cervix, which is always good, okay? If HPV is present, it will bind to this p53 gene, and there's an inhibitor that will is produced by HPV. It will bind to that p53, and that will never raise a red flag within the cell at this G2 checkpoint that says, "Hey, don't divide." Okay, so if that happens, p53 will be deactivated, and these mutated cervical cells will successfully divide. And when one divides, we get two. When two divide, we get four, and they all have that mutated gene. So eventually, that will grow uncontrollably into a tumor. Okay, and that's bad. Okay, so cancer's bad. If you can reduce your risk of cancer by getting an HPV injection, vaccination, then that's a good thing to do, right? This is a pretty good example of like how cancer usually works. But you should know, I don't know if anybody's ever taught you this before, that cancer can be a relatively normal cell division, right? So you might have normal cells that are inhibiting that p53, and that's how your cancer cells start to divide, right? It doesn't have to be produced by a virus, right? So this is why cancer is so hard to target a lot of times, because if it's not caused by a virus that you can take a vaccine for, right? Then what's the cause, right? What's telling these cells who are replicating at a faster rate, hey, you should not do that, right? Like, how do you stop that? It generally has, like, these cells individually generally have normal DNA and normal physiology. There's nothing special about these cells. They're just growing too fast. And where we see issues where we can kind of pick up differences of cancer and why different chemos and radiations and whatever work for different kinds of cancer is because if this is a cervical cell, right, one or two might not make a big physiological difference, but 4 million in a tumor might lower the pH of that area because they're producing lactic acid more often, right? If it's a different kind of cancer that breaks apart and produces a lot of smaller tumors, that buildup might never happen, right? So you can't really target it in the same exact way. So all that to say, cancer is very confusing. And this is why it's so complicated and we can't just take a vaccine to cure cancer, right? This is why when people say Cuba has a cure for cancer and the government's not telling you, that might be true, but it's probably not, because there are a lot of different physiological differences between different types of cancer, okay? Right, like these cervical cells live in a different pH than brain cells, right? So yeah, that's all I got. The other thing we could probably talk about a little bit more is endometriosis. We didn't really talk about that, and that's the end of my slides. But let me kind of show you what that looks like. I'll show you some things from Google. Right. So endometriosis is a problem in the endometrial lining, okay, of the uterus. Okay, so we see like these little ulcers right here. Generally, they're caused by like adhesions, right? So if there is a bunch of connective tissue out here, maybe this is connected to all that tissue, right? It could be connected to the broad ligament. It could be attached to other organs outside the uterus, right? Like a lot of stuff lives there. Remember, if you look at our anatomical, our female anatomy, it's a lot more. There we go. There's a lot more going on here than there is in the male anatomy, right? Like we've got the bladder right there, so it could be attached to here. We've got bones and connective tissue right here. It could be attached to, something kind of around this area. It could be the ovary itself that's attached to it, right? Because those are kind of free floating. And then there's also like other abdominal organs in here too, right? So like the rectum comes through here, and so it's like the large intestine and the small intestine, right? So that could all cause adhesions. And when you have a sorry, I just lost my picture. When you have a group of cells that their whole job is to just shed, right? They're going to take those cells with it, right? Like you have a problem with the endometrium, they're going to take those other organs with it, right? That connective tissue. So it can cause pain, it can cause excessive bleeding, it can cause other issues outside of that. You might see manifestations in like other systems, right? Like digestive systems or whatever. But mostly very painful, right? Right here to have a bunch of ulcers. Think almost like stomach ulcers, but in the uterus. Not great. Okay? That's endometriosis. I'll look at them for you. Yeah, STDs are bad. Go look up some crazy pictures. It'll make you want to be celibate. All right. That is all I have for you guys for lecture for this whole class. Congratulations, we made it. Thank you for bearing with me. I know it was painful at times. I don't blame you guys for the frustrations and the expressions of frustrations. I promise you I didn't take any of it personally. I was equally frustrated throughout a lot of things in this class, right? Because, for instance, this PowerPoint was not great, and I didn't have time to like redo it. But now that I do, you should know that if your friends ask you, "Hey, how's maths class?" you can say, "I don't know. It is going to change drastically next semester." So, I just wanted to take a moment to tell you guys thank you for being my test dummies. I'm trying to be as fair as I possibly can with like grading and stuff. Obviously, I can't like be like, "Hey, no final because this sucked." But I just want you guys to know, like, I'm trying to be as lenient as I can. As far as what the rest of the semester is going to look like, because this is the end. Next week, I'll be available for. Thank you. I don't know why you're excited for me, but I appreciate it. Next semester is going to be. Why is that not show? Show me the whole thing. No. Okay. Sorry, my computer's broken again. Next week, sorry, is going to be largely review. So we'll probably have a review session on Tuesday. We'll probably just meet normal time. And then come with questions. I would recommend coming with questions about the next test. That will open up this next Sunday. So if you guys want to wait until Wednesday to take it and have a review session, wait until Wednesday. Totally fine. I can't do a review session the week of Thanksgiving because the school's closed. So I can't be like, "Hey, you have to come online and do that." So we won't have anything going on the week of Thanksgiving. If we can just get you through the next test, I can work on trying to get some sort of concentrated study guide for the final. Just kind of know most of the final, there's a big chunk of the final that's reproductive system. Okay. So don't stress too much about, oh my God, it's going to be, digestive system and I need to go back all the way and get that. So just kind of bear with me on that one. And then our final, I talked to Dr. K about that. It has to be a live monitored respondus thing, which I'm not really sure how to use, but I'm going to play around with that too and see if I can figure it out. I'm assuming you guys are probably used to that. But I think for the purposes of keeping it easy, we should do the final on Tuesday, the 26th for lecture. And then for lab, I'm just going to open it early. How about that? How about we'll go over the lab stuff today, and then on Sunday I'll open all the lab final stuff. And we just won't tell anybody. Okay. That way you can take it, because 3 tests in 3 weeks kind of sucks. So feel free to play around with that however you want to. If it was my recommendation, I would say take the next urinary test, right? Like this final module test, and then do lab because that'll kind of help you study for the lecture final. And then on Tuesday, the 3rd at 6 o'clock, we'll do our lecture final on Respondus Live, I think. So, any course material after the midterm? Yes. For lab, I'm assuming is what you're asking. Yes. Okay. Yes. So for lab, anything after the midterm is fair game. It does totally suck. I agree. I didn't make the calendar. Blame the Mayans for that one. Which is why I'm going to open the midterm, the lab final, like probably today. So probably tomorrow, actually. I'll probably do it tomorrow. So, and I'll give you like weeks to do it. I'm not going to be like open. I'm not going to open it like during Thanksgiving week and be like, you have to take it during Thanksgiving. Even though people have to work during Thanksgiving, I have to work on Thanksgiving. So, okay. Any other questions? I will say for both finals, anything that I haven't explicitly said during a lecture, like during a meeting time, I'm gonna go through and probably filter out some of the questions that I'm like, man, I didn't even teach that. So don't worry too much about like if there's something crazy on the outline that you're like never heard of. Don't go too crazy about that. I'll try to pare it down to give you guys a study guide. I don't know. I make no promises, but I'm doing my best. So just know that I'm trying to dumb down the test a little bit because I get it. So cool. See you guys in lab. Need a little bit of a break. All right. Bye, everybody.